Tree diagrams. A tree diagram is a way of representing the probabilities of two or more events in a diagram. We often call these multi-stage events. To calculate probabilities using a tree diagram, you multiply along the branches. Hopefully someone after viewing this video would be able to calculate probabilities using a tree diagram. MP2, reason abstractly and quantitatively. MP4, model with mathematics. MP5, use appropriate tools strategically. And some keywords are independent probability and tree diagram. So for starters, I flip two fair coins. What's the probability that I flip two heads? What's the probability that I flip one head and one tails? You can draw a diagram or a table if it helps you. Here's a table. You could fill in all the possibilities. So coin 1, coin 2, and you could calculate those probabilities. So the AND rule for probability. To work out the probability of two events both happening, consider their individual probabilities. The first coin's probability of heads is 1/2. The second coin probability of heads is also 1/2. The probability of two heads is 1/4. Can you figure out how to get 1/4 from those 1/2 and 1/2? If you guessed multiplication, you are correct. The probability of events A and B happening, you take the probability of event A happening and multiply it by the probability of event B happening. So this is true when the events are independent. So the probability of A and B, which notice from set theory notation is A intersection B, when two events are independent, the probabilities of both occurring is the product of the probabilities of the individual events. Remember, an independent event is where the outcome of the first one does not affect the outcome of the second one. So if you flip a fair coin twice, what's the probability that it will come up heads both times? That would be 1/2 times 1/2, which is 1/4. Let's look at it in a tree diagram. If I flip two coins, what's the probability I get two heads? Our first branch of our tree will be coin 1, and our possible outcomes are heads and tails. Our second branch of our tree is coin 2, and again, our probabilities are going to be heads and tails and heads and tails. You might see where that denominator of 4 comes from, because there's 4 possible outcomes. We could get heads, heads, we could get heads, tails, we could get tails, heads, or we could get tails, tails. So if you follow along a branch, that's how you would get the outcome. So you can write in all these probabilities and see the calculations. The probability that coin 1 is heads is 1/2. The probability that coin 1 is tails is 1/2. So you can see 1/2 plus 1/2 is 1. So those are all the probabilities of coin 1 happening. That's what this says right here. Probabilities on each branch add up to 1. Now we're here at coin 2. Notice we have different branches, because if we follow along this branch, that means we got heads on the first coin. So if we got heads on the first coin, what's the probability we get heads on the second coin? Well, it's still 1/2 because these are independent events. What's the probability I get tails on the second coin? Again, it's still 1/2 because they're independent events. Same if I got tails on my first toss. I still have a probability of getting heads of 1/2 and tails of 1/2 on the second toss. So notice we can multiply along the branches. 1/2 times 1/2 is 1/4. Now you can see these 4 outcomes. And if you sum all of these, 1/4 plus 1/4 plus 1/4 plus 1/4, you should get 1, because that would be the total probability. So you can use tree diagrams to help you in these problems. You can try a couple of these. You can use a tree diagram, or you don't have to. If you flip a coin and roll a 6-sided dice, what's the probability that the coin comes up heads and the die comes up 1? Remember, these are independent events because it doesn't matter what I get on the coin. It doesn't affect my dice. So the probability of heads and a 1 would be the probability of heads times the probability of 1, which would be 1/2 times 1/6, which would be 1/12. Here's another one. You draw a card from a deck of cards, put it back, then draw another card. What's the probability that the first card is a heart and the second card is black? So remember, it's an intersection. So there are 13 hearts in the deck, 13 out of 52, times there are 26 black cards in the deck, so 26 out of 52. It's easiest if you simplify those first before you multiply them. So 1/4 times 1/2 would be 1/8. So the probability that the first card is a heart and the second card is black is 1/8. You could look at that in a tree diagram as well if you chose to.